So the next question, how does the resistance of a wire change when its length is tripled? Okay, so how does the resistance of a wire change when its length is tripled? Okay, first of all, we know that resistance is directly proportional to the length. Resistance is directly proportional to the reciprocal of area, or you may say it is inversely proportional to area, and because of which we get a constant, that's rho L by A. So this is the final relation that we have established from the topic resistance, right? That resistance is directly proportional to the length, because we know as the length of the conductor is increasing, the resistance will increase. As we have a thick wire or thin wire, or maybe we have a bigger tunnel, small tunnel, we have seen how the resistance is an important factor in that case. And lastly, the constant, that was the nature of the medium, or you can say the nature of the material. That means that is what we represent it by rho, clear, at a fixed temperature. This is what we have found out the various parameters. Now first of all, we will see what happens if the length is tripled. Okay, so first of all, normally my resistance was rho L, L1 and A1, let's say. So the first case resistance is R1 is equals to, since after you are not changing the medium, or you can say the material, so the resistance is rho L1 and A1, fine. So that's for the first scenario, right? The resistance is this. Okay. Next, what happened? Next, L2, there was a new length. Okay. What happened to L2? L2, the information that they are providing is that the length is tripled. That means what was my previous length? L1. Now the length has become triple. That means 3 times of L1. So L2 is 3L1. Fine. So how are we going to write the resistance at case 2, or you can say scenario 2? Resistivity is the same because we are not changing the material. Now L2, because we have changed the length. Okay, did we change the area for the first part? No, we haven't. So let it be A, though it's A1 here written. So we can just write here like this, that A1 equals to A2 equals to A. This is what we can write. Fine. So what we can do, one second. We can just write like this, rho L1 by A. Clear? Fine. And what is the parameter that has changed? That is L2 equals to 3L1. Fine. Now rho L2 we can substitute with by this, that is 3L1. A2 we can write as A2, A1, and also A, because after all they are same. Now if we segregate them, don't you think we got a similar expression? What is it? R1. That means 3 times of my old resistance. Fine. That means my new resistance will be 3 times of my old resistance. What does it mean? It means without calculating again a lot of things, if you see only the length has changed to 3 times, just directly, means 3 times, 4 times, whatever, just directly multiply the resistance with that amount of factors. Clear? So let's say the length of this is 30 ohm. Now the length has changed to let's say by 4 times. That means usually the resistance was how much? 30 ohm. Now since the length has changed to 4 times, that means it will become now 120 ohm. Clear? Because that's the reason this type of expressive point based question comes. That means when other factors are fixed, we can just see which is the factor that is overall changing. We can just use that and solve the problem rather doing it again as a whole. Clear? Okay. So next question comes here. If the diameter is tripled, okay, so again we will do R1 equals to, now this time my rho is fine, we don't have a problem. Length we can keep it as it is because length is again a fixed factor. Then the diameter has changed. Okay, now before that, since we are always talking about the cross section, that means cross section means we are talking about a circle, means a circular part, right? Same thing, circular, so that means pi r square. Okay. Now we know that initially my D1 equals to 2R1. Fine. Okay. So I will just write here, that means since they are talking with diameter, so I will be expressing the answer in the form of diameter. Fine. That means R1 is equal to D1 by 2. Now pi R1 square, that means D1 by 2 whole square. Clear? Okay. Now what's the answer? That means rho L pi D1 square, and down it will be 4, right? It will be here 4, just it will go up, that is rho L pi d1 square, and here it will be 4. Clear? So that means my resistance for the first scenario is, I'll just write it more properly, R1 equals to 4 rho, that means my resistivity, L divided by pi d1 square. Clear? Did you understand the old I mean to say, before any changes have been made, what is the resistance that we have expressed it in this way? Clear? Now we are going to find out the resistance for the new case. Now in the new case, my diameter, the diameter is there saying it gets tripled. It gets tripled. That means 3d1. Fine. Instead of 3d1, I can write here, means what I'm trying to say, yeah, let it be 3d1 now only. Okay. Now again the same story. R2, now we know here that L1 equals to L2 equals to L, and since we did not change the material, so my resistivity will be the same. Clear? So now R2 is equal to rho L by A2. Why? Because since my diameter has changed, that means it will have an effect on my area. Okay, so rho L A2. A2 means pi D2 by 2 whole square. Correct? Yes or no? Okay, fine. Next, so rho L square pi d2 square upper, it will be 4. Fine. So we got a kind of same equation. Now what we can do is we can substitute this d2 with d1, because they are saying that what was my old diameter was d1. Now it has changed to 3 times of my old diameter. So I can just replace. That means what I will do here, 4 rho L square pi. Fine. Now d2 is what? 3d1. 4 rho L square by pi 9 d1 square. Right? Fine. Now we will segregate them. That is 1 by 9 into 4 rho L pi d1 square. Did you understand here? See, we got the same expression, right? So if now I try to segregate this, fine, I can express it in what? In my old resistance. Fine. That means my new resistance will be decreasing. That means it will be 1/9 of the resistance which was offered in the first case. Clear? That means what? If my length is increasing, my resistance is increasing. And if my diameter is increasing, area is increasing. And if area is increasing, means resistance is decreasing. Yes. Clear? Next. Its material. Now we will come to the next point. Understood till this much? Fine. So I'll just give one wrap up. See, here resistance is depending upon the length, is depending upon the area, and this is what we have established the relation. Now we have, first of all, for the first case, we have found out that my overall, that means my final resistance, that is R2 is equal to means my resistance is increasing by 3 times. Therefore, resistance is increasing by how many times? 3 times. 3 times of old resistance. Fine. Next case, when my diameter has, in this case, what is happening? It is 1/9 of old resistance. Clear? Okay. Last, its material is changed to one whose resistivity is 3 times. Now this time what we have done is the resistivity has been changed to 3 times. That means now the material has been changed. Okay. So how are we how am I supposed to do this? R1 is equal to rho 1 L by AY, because we know length is also fixed, area is also fixed. Okay. That means this is what is my expression. Okay. Now my rho 2 has changed to 3 times of my old resistance. Fine. That means my R2 will be rho 2 L by A. Rho 2, instead of rho 2 we can write here 3 rho 1, 3 rho 1 L by A. Then we will just segregate this part, that means 3 R1. That means if my resistivity is increasing by 3 times or length is increasing by 3 times, we need to increase my total resistance by that amount of times. Clear? Only for the area we need to be, that is, it is decreasing to 1/9. Clear? That means overall we have understood this part. That if my length is increasing, resistance will increase. If my diameter is increasing, resistance will decrease. If my resistivity is increasing, then my resistance will also increase. Clear? This is how you need to break a big problem into sub problems and try to grab the answer. Clear? Okay. So let's come to a new question. Okay. What is it? A piece of wire of resistance 20 ohm is drawn out so that its length is increased to twice its original length. Calculate the resistance of the wire in the new situation. Okay, so this question is a bit tricky. Okay, let's see. Why did I say it tricky? Okay, let's see. So previously we had certain question, if the length is tripled, the resistance is tripled. If the length is decreasing, then resistance is decreasing. This is what we told with the fact. So before understanding this question, let's say I have taken a wire. Okay, let's say I have taken a wire. Fine. So initially my length was L1 and now my length is L2. Fine. Now when in this case, did your area change? What I am trying to say is, if I say I have given a piece of wire. Now I said no, not 5 meter, make it 10 meter. That means you will take another wire, or you may take a new wire and which is of length, let's say 9 meter or 5, whatever, means according to your desired. That means out there area is not a constant. Fine. So whether you are considering the area for this wire or this wire, my area is fixed. Yes or no? Because after all my radius is not changing. Area is dependent on the radius or the diameter, whatever. So if my radius is not changing, that means my area is the same. That's the reason we can easily say, array, resistance is also tripled when the length is tripled, this is. But this question is not like that. This question they are saying it is drawn out. Drawn out means is just you take a dough of, let's say, this much amount of length, okay, and you just try to pull it with the same amount. You are not taking any new wire, or you are not even segregating the piece of dough that you have already received. Clear? So that means in this case what happens is there is a freedom that you can take a new wire, you can attach a new wire, you can do various things. But in this question, in this scenario, you are not allowed to attach, cut anything. Whatever amount of wire it has been given to you, based on its malleability property and ductility property, it has been drawn out. That means ductility, right? Okay, so that means this wire has been, the wire has been elongated. Fine, you have not attached any wire from any external. The questions that, or the expressions that we have derived so far is that you were allowed to take it. As a result, my area was fixed. Now in this case, we can't help, the amount that has been given to you is the same. Now when I say the word amount, that means the amount I have given. Now definitely mass do not have any dimensions, but do you think volume has? Yes, definitely, because we know that volume is what? 3-dimensional. That is, it is the product of area into length, or area into height, or area into breadth. That means we have total 3 dimensions in volume, right? And in which the cases for resistance we have A also, with resistance in the case we also have the L. That means I have given you the fixed amount of volume. Now with that amount of volume, let's say you have been given the volume as any number, let's say 48. Okay, let's say 48. Now let's say your area is 12. That means your length will be what? 4. Okay. Now if you want to increase it, let's say if you want to increase it, then definitely your length will decrease. If you increase it by 2, the length is going to decrease by 2. Okay. Now if you want to decrease the area by, let's say 8, then this will be how much? 6. Clear? Understood? Is it Fine. Yeah. See, this is increasing, this is decreasing. Fine. So that means we can have the fixed number of volumes. Now you can design your own wire, whether you want to make it 8/6, 12/4, 24/2. Did you understand? Did you get the idea? That means here my volume is fixed. Clear? But now you have to find out what is the situation. So for the first scenario, where my R1 equals to 20 ohm. Fine. So when my R1 is 20 ohm, we have rho, we have L1 and we have A1. Clear? This is what we know. Clear? Now we want to find it for the new, fine. I'll do it. I'll just erase this so that it's easy for me to explain. Okay, that means my R1 is equals to rho L1 A1, because that was the first pair of length and breadth, and which is 20. Clear? Now what happened? My length has increased. Now let's see, for these volumes are same, right? V1 equals to V2 is equal to V. This is same. Now in the first case we had A1 L1, and in the next case we have A2 L2. Clear? Now they are saying the length is increased twice its original length. Fine? That means L2 equals to L1 into 2. Clear? Now see, after all we have to keep the volume same. So if my L2 has changed to L1 into 2, that means, and here my V is fixed. Okay, here, so if I have taken, let's say from A2 I have taken a 2 factor out here, that means we have to divided. Did you understand? That means, again I repeat, okay, that means I have to keep my volume fixed. Okay, my length has increased to twice. Fine. Now if my length is increasing to twice, that means my area has to decrease by half. Why? Because if I am taking a 2 factor, let's say some value was there, I have taken a 2 factor from there, that means what? It is getting, that means my new area is, that means my, you can say, that means here it was, what is it? I'll just, wait just a second. Okay, what I am trying to say is A2 and L2, clear? Now what is my A2? I have no idea about my A2, okay? That means I will objectify. Fine, we will find out what is the value of A2. That means V by L2. Clear? Now L2 is how much? 2L1, yes or no? Clear? Now again I will segregate. How? I will write here half V by L1. So I want to find out what is my A2, correct? And this is what I have found out. Now you see here, V is equal to L1 and V is equal to, with this relation, I can pull out this relation stating that A1 is equals to V by L1. Right? I can extract the relation with this factor, that if I want to find the area of the first case, then I will write what? V by L1, that means volume by L1. So don't you think here we are getting the same thing? So it's half of A1. Clear? It's pretty easy. That means what is it? First of all, okay, let me do like this. I'll just take it afresh. Okay, first what happened? My resistance was this, and we know that volume is equal to L1 into A1. Clear? Okay, and since we have already started, so we know that we have to objectify A1. So I will just write here the expression for A1. Clear? Now resistance 2 equals to rho L2 by A2. Clear? Now rho L2 is how much? L2, they are saying it's twice of the original length, so it's 2L1, and A2 what we will do is, A2 we will write here as V by L2. Clear? If in this case my volume, we can express it like this, then here also we can write here volume is A2 L2, and we can write here A2 is equal to V by L2. Clear? We can write like this. Okay, that means now again L2 we can substitute by 2L1. Okay, so rho 2L1. Okay, now V, now upar it will go here L2. Okay, now what is my L2? 2 rho L1. Again we can write here 2L1 by, where is it? The volume, no? volume. Okay, now volume means what? What they are asking? The resistance now. Okay, not a problem with that. I can just express it, not a problem. Okay, 2 rho L1 into 2L1. So we can write here as A1 and L1. Why? Because see, we can write it A2 L2, but I want to express it with the help with respect to the old resistance. So we have to induce all the parameters of the old resistance, that is A1 and L1. So volume I can replace it by L1 by A1. So L1 gets cancelled. Okay, so 2 2s are 4. So 4 rho L1 by A1. Clear? Now I will segregate this part stating it is the old resistance, right? That means if my wire is drawn out keeping the constant, what constant? Volume constant, where you are not allowed to attach, detach any piece of wire, and if such the case, then my length and my area is definitely going to change. Now how they are going to change? This is what it is already shown here. So that means this is just a substitution of the letters. That's all, means the variables we have taken, and finally we have expressed the answer as 4 times of the old resistance. Clear? So now what is my R1? 20 ohm, and R2 4 times of R1. So now it will be then together, means all total it will be 80 ohm. Clear? Understood? So if my resistance, if my length has been increased by 2, that means my area needs to be decreased by half, since my volume needs to be constant. Clear? Always keep things, you have to keep maths also in your mind, physics also in your mind. That will make up science. Clear? Okay. Next question. If the radius of a current carrying conductor is halved, how does the current through it change? Okay, let's see. So if the radius is halved, how does the current change through it? Okay. So first of all, R equals to rho L by A, right? Now if the radius is changing, that means, okay, see, do you have your any expression with current and resistance? What we can see? Let's see. Okay. First of all, we have to also keep this thing in our mind, that is Ohm's law. That means we need to establish the relation between resistance and current. So keeping the voltage constant. So I equals to, if you take here, right this side, let's say whatever, that is V by R. Clear? V by R. So that means if it's V by R, that means this is 1 by R, that means I will be inversely proportional to R. Okay, this is what we can get we can establish. Okay, so first of all, let us see if the radius is increased. Okay, so in this case it will be rho L1 pi R1 square. Clear? This is what we have. Okay, fine, we have this. Okay, next R2. Okay, my new resistance, if my radius is halved, my radius has become halved. So L1 is it's a fixed because my length is not changing. So L1 by pi. Now this time what happened to my radius? It got halved. So R1 by 2 whole square. Okay, so L1 by pi R1 square, and upper 4 will go, right? So 4 will go up. So it is my 4 times of my old resistance. Clear? Now we will establish this. So I is inversely proportional to, okay, let me not write here as inversely proportional. With respect to I, first case, I equals to V by R1. That means V by rho L. Since my length is same, I will not write here 1. Okay. So R. Okay. Rho L. Here also I will write here rho L. Clear? No L1 because it will just create a bit confusion. Here everything is the same. Okay. Rho L, it will be up, it will be pi R1 square, right? So my I1 is directly proportional. If I now, this is constant, this two are also constant. So directly is R1 square. Fine. That means if I want to find out for R2, if I want to find it, now what happens? I1 is this. Okay. Now this is for what? Current 1. Clear? Now we have to find it for current 2 as well. That means what happens if my radius is changing. So let's do this. So resistance 2 we have seen, so that in resistance 2, where is it? It is 4L, again the same story. It will be rho L. Clear? Don't write L1 or something, fine. Just keep it normal. That is rho L by pi R1 square. Where is it? Yeah. So pi R1 square and oh, I have erased 4 because 2 square up it will go 4. Fine. So this is what we have done. Clear? So I'll just put here once again. R2 is equals to rho L. A means pi R1, since it's get divided, so it's R1 square, and up 4 it will go. This is what we have the resistance. Now I2 is equals to V by R2. So V by R2 means 4 rho L, and up it will go here pi R1 square. Now 1 by, okay, so if you see here, where is it? Normal we have kept, that means which are the factors that we have kept constant? The factors that we have kept constant is voltage, pi, rho and L. Rho means as in resistivity. This is something that I told to keep it as constant. Fine. Now let's go to the next part. So V, pi, after that rho L. This is what I asked you to keep constant, and pi, oh, pi is already given. Okay, R1 square, 4 is down. Okay, fine. So this is kept constant, so it will be proportional to R1 square by 4. Clear? I2. Fine. That means my I2, if my radius is changing, is directly, means what I am trying to say is now my R1 square is also fixed. Means what I am trying to say, if I want to express it now, I2 equals to, till this much we were having I can say till this much, right? Only this part if you extract, let's say we are representing this part, let's say this is K, let's say V pi R1 square by rho L. Okay, let's keep this as constant. That means it will become K by 4. What I am trying to say is that if you have this factor as constant, fine. If you keep this factor as constant, what I am trying to say is, see, V, okay, this is rho L divide by, that means here it will go pi R1 square. This is what we have, no? So clear, this is what we had initially. So let's represent this thing as K, this whole thing, V pi R1 square and rho L, and then shift it to the next slide. Means next we can use it that pi and everything we have used it as K. That means what we can do is we can write here K by 4. That means if my resistance, if my radius is halved, are you imagining, if my radius is halved, my current is going to decrease. See, if my radius is halved, my current, initially my current was what? I1 equals to K, where is it? Equals to K. This time the value became K by 4. That means my current has decreased. If my radius is halved, my current is decreasing to 1/4 of old current. Did you understand how this became? Because definitely if your radius is decreasing, you are making the tunnel narrower. Don't you think it will be very discomfort? It will be, the current will flow, it will become less as it is less. Understood? So this is how you need to segregate. Okay, why I have taken a variable? Because in the same because in the previous, like what I am trying to say is, when I was finding for I1, I thought these are all same. So I let me take this one into a single as a, because there's a lot of factors, right? So I told, let's, okay, chalo, let us take for a single variable, and just the thing that I have changed is K by, it became K by 4. Just I have segregated this part. So in order to understand, you can do all this, okay, not a problem, but you have to be very logical. So if my current is, this radius is getting halved, that means the tunnel is becoming narrower, it's difficulty for the people to go, that means for the electrons to go, current is decreasing. Clear? Okay, this is an interesting question. The electric resistivity is all very interesting, but still this is a bit change. The electrical resistivities of 4 materials, that is A, B, C, D, are given below. Which material is a good conductor? Fine. Resistor, insulator and semiconductor. Okay. So what I will try to do is, first of all, though here a bit presentation is a bit mistaken. Okay. So 10 into 10 to the power minus 8 ohm meter. These are all resistivities. Okay. Next 110. 10 to the, what is the meaning of resistivity? That means if you have a length of 1 meter and area of cross section as 1 meter square, then you are going to get this as resistance. Okay, this is done. Okay, this is just a presentation mistake was there. Okay, now first is we have to go with first insulator. That is the most easiest thing. Insulator is the highest resistance. Now since these two are negative resistance, we will keep this aside. Now these are the two positive resistance. Now 10 to the power 10 and 10 to the power 3. Definitely this is the largest. This is the largest. Fine. If this is the largest, that means this will be my insulator. Fine. Clear? Okay. Next. Okay. Next is, if you see the minimum resistance, that will be my conductor. So, this is positive, we will not see this, we will see this too. Okay. So, one is 10 into 10 to the power minus 8, which means 10 to the power minus 7. And other one is 110 into 10 to the power minus 8, which means 11 into 10 to the power minus 7. So, one is 1 into 10 to the power minus 7, other one is 11 into 10 to the power minus 7. So, which is smaller? This one, that means, where is it? 10. That means this we will consider as, which one? Understood? No. One is, I'll just explain once. One value you got as 11 into 10 to the power 8 ohm meter, and other one you got as 1 into 10 to the power minus 7 ohm meter. So again, see, if since I'm trying to compare, I'm trying to make the powers of 10 also same, so that I can get the, or here the value I can get and I can easily compare. So one is 11, one is 1. So that means I'll go with the 1. That means this will be my conductor. This will be my conductor. Now, you have to understand this thing that if you, let's say we don't have any idea about the semiconductor. So, how will you solve this question? Insulator and conductor was easy, but how will you solve for insulator and semiconductor and resistor? Do you ever hear that semiconductors are used in electrical circuit, like whenever we take examples? No, we always use resistors. That means resistors are far better than semiconductors. So if resistors are far better than semiconductors, that means you have to see this, that resistance, okay, that means resistor will have a resistance less than the semiconductor or the resistivity material. That means this will be my semiconductor. Because semiconductor, no, resistors are already conductors. Otherwise, how is the current flowing through that? Okay, means not better than conductors, but yes, better than semiconductors. That means this will be my resistor. Understood? Fine. Okay, so did you understand about the conductor, resistor, insulator and semiconductor? So this is how you are going to, separate. You are going to understand the difference between conductor, resistor, insulator, semiconductor. So the highest resistance will be definitely for insulators, then for the means the highest, okay, and the lowest will be conductors. So now in resistors and semiconductors, the semiconductors though you have no idea about the semiconductors, how the conduction happens in them, but resistor we use in the circuit. That means resistor is already a conductor which allows the flow of current. Let's say not like conductors, but definitely it is conducting, but semiconductors we don't. So that means the resistance of the semiconductor will be more than the resistor. Okay, and one more thing, just a general fact to remember, that if I consider the alloys like manganese, chrome, even if you increase the temperature, the resistance remain unaffected. Why? Because there the resistance is already huge. Okay, you have seen the resistance of the nichrome wire is 60 times that of the copper. So that means the resistance out there is already huge. As a result, we don't need temperature, it's already high, so it doesn't have any effect as such. Okay, so these are all the things. Okay, thank you guys for watching this video. If you really find this videos informative and helpful, please do subscribe my channel Vigyan Jyoti, hit the like button and share it with your dear and near ones. And yes, please don't forget to comment, because your feedback does matter.